Hi guys, welcome to today's lesson. It's called Comparing Fractions. Write the title, write the learning objective, rule off from your last bit of work. Pause the video so that you have time for that and press play when you're ready to keep watching. So, the last lesson that you did before half term involved converting fractions to decimals. Now, today's lesson is about comparing fractions. If you're asked to compare a fraction with a decimal, for example, which is bigger, 3/5 or 0.55, what do you think you should do? You thought of it? We can't compare two things unless they're in the same form. And at the moment we've got one fraction with one decimal. So what we've got to do is either convert the decimal to a fraction, which we've not really done much of, so I'm not going to go into now, or we can convert the fraction to a decimal. 3/5, now you may know this automatically just in your head, or you could do 3 divided by 5, and the numerator always goes inside the bus stop. Write some zeros. 5 goes into 3 0 times with a remainder of 3. 5 goes into 36 times. And so now you've got a situation where we've got 0.6 or 0.55. It should be fairly easy to compare those, get the place value columns going, and you can see that going from left to right, they've both got 0, but then there's a 6 rather than a 5 in the tenths column, and so therefore this one's bigger, which means this fraction is bigger. So hopefully you're clear about that because you've been doing a lot of practice about converting fractions to decimals. Today's lesson is about comparing fractions with fractions. So, I'll give you a little example here and see what you make of it. If I said, write the following in ascending order, and we've got these fractions. I want you to pause the video and have a go at doing that however you want. So whatever method you want to use, have a go, and press play when you're ready for me to go through it. So this question here, this example, call it EG1, you could use a method in terms of what the learning objective is talking about, finding the LCM of all the fractions, but I would hope that you can look at these fractions and just know that this one here and this one here, they're less than a half. If I drew them out as pictures, get my little pizzas going again, 1/6 is just 1 out of 6, so it's obviously much less than a half. 2/5 is 2 out of 5, and it's obviously less than a half. So we know that these two are going to be smaller than a half. We also know that 3/4 is bigger than a half. You split it into 4 parts, 3 of them out of the 4 is bigger than half. So straight away, hopefully, without having to do any calculations, you could say that 3/4 was the biggest, a half was the next biggest, and then between 1/6 and 2/5, hopefully you can just see or think in your own head without even drawing the diagrams, 2/5 is bigger than 1/6. When you have 1/6, each of the individual parts is smaller than when you have 1/5, but the fact that we have 2/5 means definitely for sure 2/5 is going to be bigger than 1/6. So we don't even really need to do a method for that. We can just kind of think about how big these fractions are compared to each other and compared to a half and figure it out from there. This is a situation when finding the LCM would not be necessary, in my opinion. I would hope that you could just do these fractions, put them in order in your head. And remember, ascending means smallest to biggest. We're going to look at another example now, and I want you to decide whether or not you could do it in your head. This time we're going to do 3/4 3 over 2, 3 over 5, 3 over 8, and 3 over 6. Do you think you could put those in ascending order? Pause the video and have a go. Well, again, I'm hoping this is a situation where we don't need to do any calculations to know which is the smallest and which is the biggest. But just in case you're not clear, I'm going to draw some diagrams just so that you can see. Imagine I've got 3/4. You can see I've got 3 out of 4. 3 over 2 means I've got 3 halves, which actually means I've got 1.5 wholes. That's an improper fraction, same as 1.5. 3 over 5, split it into fifths. See, I've got 1, 2, 3. 3 over 8, split into eighths. I've got that much. And 3 over 6 is the same as a half. I've got that much. What do you notice? Well, clearly, the thing that we have the fraction which has the least value is this one here, because the smallest amount of the circle is actually coloured in with the 3/8. So 3/8 is the smallest fraction. Then looking at it, I can see the next smallest is this one here, the 3/6. There's half of that's drawn out or coloured in underneath. Then it looks like the 3/5, this one here. Then it's the 3/4, where almost all of it is coloured in. Finally, it's the 3 over 2, where I've got more than one whole. What's the pattern that you notice here with our answer? Can you see a pattern? Pause the video if you haven't yet spotted it. Give yourself more time to think. Well, hopefully you've noticed when the numerators are the same, the bigger the denominator, the smaller the value of the fraction. I'll say that once more. You may need to rewind it to really understand what I've said. When the numerators are the same, the bigger the denominator, the smaller the overall value of the fraction. So when the numerators are the same, again, we don't need to really do any maths. We don't need to do any calculations, at least, in order to say which is bigger or smaller. The bigger the denominator, the smaller the overall value of the fraction. So this is another situation where if we look at the learning objective, we do not need to find the lowest common multiple to compare the fractions. So write that down if you didn't already know it, about when the numerators are the same. And then we're going to do another example. This is actually the third example. I forgot to move it on last time. Sorry, guys. Now, sometimes it's not as easy as being able to just look at the fractions and say, yes, okay, that one's the biggest, that one's the next biggest, that one's the next biggest, etc. And here is a question where actually you may do some calculations in order to compare the fractions, because the numerators aren't the same size, and you can see that every single one of these fractions is less than a half, apart from the actual half itself. So we probably know that the half is going to be the biggest fraction if we're writing them in ascending order, smallest to biggest. But what about the other 4 fractions? This one, this one, this one, and this one. How can we compare these and put them in order? So I want you to pause the video and have a go at this now. Press play when you're ready for me to go through it. Well, the method for comparing fractions, when it's not obvious how to do it, is we're going to find the LCM. LCM means lowest common multiple. And so what we need to do is we need to find the lowest common multiple of all of the denominators, just like as if we were adding fractions. or subtracting fractions? Remember adding and subtracting fractions? Find the LCM. Well, there's another chant. Comparing fractions, find the LCM. But only if necessary. So if you can do it in your head, then obviously go for it. But if you're not clear, what we're going to do is find the LCM. So can you see the LCM of 12, 6, 2, 8, and 4? Can you picture it? If you can't think of it, you can always write out the times tables of all these numbers. I'll let you do that now if you haven't already spotted what the LCM of the denominators is. But I'm telling you now, the LCM is 24. 24 is the first number that goes in all of their times tables. And so now, we have to find equivalent fractions, do it to the bottom, do it to the top. 5 over 12 is the same as 10 over 24. 2 over 6 is the same as 8 over 24. A half is the same as 12 over 24. Three over 8 is the same as 9 over 24. And 1 over 4 is the same as 6 over 24. Now that all these fractions have the same denominator, hopefully it's fairly simple how we put them in order. From smallest to biggest, it's just going to be the fraction which has the smallest numerator. Because clearly 6 over 24 is going to be less than all the others because they're all out of 24 as well. So this is my smallest fraction, 6 over 24. The next smallest, the 8 over 24. Cross these out as I do them. Next smallest is the 9 over 24. Then the 10 over 24. And then the 12 over 24. But can you see the problem with what I've just done? I was asked to write the fractions in ascending order, but I've got here 5 different fractions to what I had in the original question. So what I need to do is write out the original fractions that I was given, not the fractions that I've written to compare them. So I'm going to go back to my original question. 6 over 24 was the same as a quarter, so I'm going to write that first. 8 over 24 was the same as 2/6, so I'll write that next. 9 over 24, 3/8. 10 over 24, 5/12. And 12 over 24 was a half. And this is my answer. So pause the video, make any notes that you need to. I've done quite a lot of working out here. You don't necessarily need to do this amount of working out, but if you need to, you must find the LCM. Let's do it again. Comparing fractions, find the LCM. Comparing fractions, find the LCM. Adding and subtracting fractions, find the LCM. Comparing fractions, find the LCM. Really hope you're joining in, otherwise that was probably very boring for you. So let's do another example. It's not example 2, it is example number 4. So I want you to place the following in descending order. Pause the video so you've got time to do that and press play when you're ready to keep going. Alright, so I can see all of these fractions apart from the half, they're all greater than a half. So I'm going to probably need to find the LCM to compare them. Fair enough. So what am I going to do? I'm going to find the LCM of the denominators. So the LCM of this, 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 and this. Well, I'm pretty good with my times tables, and I can see the first number that's in all of their times tables is 30. So I'm going to write them all over 30, like that. This one, the 5, I'm going to times it by 6 to get 30, so I'm going to times the 3 by 6. 15 I times by 2 to get 30, so I times 11 by 2, and I get 22. 3 times 10 makes 30, so 2 times 10 is 20. 2 times 15 is 30, so 1 times 15 is 15. And finally, 6 times 5 is 30, so 5 times 5 is 25. Now that I have all these fractions with the same denominator, I can write them in order. So I can see the smallest of all of these, I knew this already, was a half, the 15 over 30. I'm going to write the original fraction first. Ooh, have you spotted my mistake? Descending. Descending means biggest to smallest, which means the half is actually the smallest fraction that I should be writing at the end. So let's find the biggest fraction, because that's what I'm going to be starting out with biggest to smallest. And I can see it's the 25 over 30, which is the 5 over 6. That's the biggest. Next biggest, 22 over 30, 11 over 15. Next biggest, 20 over 30, which is 2 over 3. Next biggest is 18 over 30, 3 over 5. And then the half is the smallest. So the message from this, guys, is if you ever can do it in your head by comparing the numerators or by understanding that some of the fractions are bigger than a half, some of them are less than a half, then please go for it and do it in your head. But if necessary, comparing fractions, find the LCM. So make sure you've written that down in purple pen, and then good luck with today's Hegarty quiz.